and welcome to this question right here. Today we'll be discussing how you can calculate the concentration of hydronium ions from a given pH and the color of a given chemical indicator. So let's begin. The question states that a student is given a solution that he is unsure of, but he does know for a fact that the pH is 3.5. Part A states that we need to calculate the number of hydronium ions, or the H3O plus ions, in that solution. And it's really easy. All we have to do is manipulate the equation for pH. Now that equation looks like this. pH is equal to the negative log of hydronium ions. Now what we're going to do is we are going to solve for the unknown, which is the ions. We already know the pH, and so we're going to manipulate the equation in order to solve for it. First thing you're going to do is divide by -1 on both sides. So you get negative pH is equal to log of the ions concentration. Okay, easy enough. But now we have to convert it into exponential form. We don't want it in logarithm form, otherwise we'll never find out the answer. One thing that you have to remember is that we're taking a common log. Common log states that the base will be 10, and that's because the pH scale is based on a 10-fold scaling system. This means that something with a pH of 1 is going to be 10 times as more acidic than something with a pH of 2. And the same goes with bases and any other given point on that scale. So let's do this. What we're going to do is we're going to put base 10, which is right here. That is our base. So we're going to place it right there. The next thing that we need to keep in mind is that this right here is our exponent. And so we're going to place that right there. And then what we're trying to find out is the H3 plus ions, and that is exactly what we found out right here. With just simple manipulation, we can find out the concentration. So let's plug in the values we know and solve. All right, so 10 raised to the power of negative 3.5, which is the given pH, is equal to the concentration of hydronium ions. When you calculate this out, you're going to get an answer of 3.162, blah, 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 blah. Goes on and on, times 10 to the -4 moles per liter, which is equal to your concentration. Now, in terms of rounding, there are 2 places here, which means that we're going to take 2 decimal places. So our final answer is going to be 3.16 times 10 to the -4 mole per liter. And that is our answer for part A. Now let's look into part B. It asks, what color will the solution be if this student added methyl orange, which is a chemical indicator? We're given a little bit of information here so we don't go running into the dark. We're saying that the pH range before it changes is from 3.2 to 4.4. And at that given moment, the color is going to change from red to yellow. Let's distinguish where our pH falls into this range and then find out what color it'll be from there. So 3.2. Our pH is greater than 3.2. So let's just put that sign there. However, our pH is still less than 4.4. This means that our given pH can't be red or yellow. because in order for it to be red, it needs to be less than 3.2. And in order for it to be yellow, it has to be greater than 4.4. We're in between. So what we're going to do is we're going to find a color that is in between them. And if we mix these primary colors together, we're going to get the secondary color of orange. And that is exactly what the color of our solution will be if we add methyl orange to it. I hope this helped. Thanks for watching.